Hi, good evening, everyone.
Good evening, sir.
Yeah,
Good evening, sir.
so we'll add few more minutes so that more students can join. So once again, good evening. I think we can start. So today first we'll discuss B tree and B plus trees. After that, we'll take your doubt. So let me share my screen. Okay. So my screen is visible, right?
Yes, it's
Yes,
visible.
sir. Yes, sir.
Okay. So today we'll discuss B tree. So first we'll discuss how structure of the B tree. So structure of the B tree like that. So K1, K2, and the this represented keys, and this PR1 and this PR minus 1, these are represented record pointers or data pointers, and these are represented block pointers or child pointers or tree pointers. Okay, so suppose uh, in uh, in B trees, order is P. P order means maximum numbers of child pointers or block pointers is P. Maximum numbers of child pointers equal to P, and the maximum numbers of keys P minus 1, and maximum numbers of record pointers also P minus 1. So see, child pointers means refer to the left means subtree, like right subtree or left subtree, and there is rules like if this should be less than the value of K1, and like this should be greater than the value of K1, and record pointers point to the actual data address of the data it will represent, means it will give the address of the data. So everyone understand the structure of the bit tree?
Yes, sir.
Okay, so so how to construct a bit tree? So order 3 means maximum numbers of block pointers equal to 3, and the maximum numbers of keys equal to 3 minus 1, 2, and maximum numbers of record pointers equal to 3 minus 1, 2. So okay, so construct a 3 order bit tree, and the values are 20, 50, 40, 80, 90, 10, 30, 70, and 60. So let's insert the data first. So 20, this will record pointers. Then let's insert 50. This is record pointers. Okay. So when we insert 40, so maximum numbers of keys is true, right? So 40 should be insert in this position. So it should split up, right? Hello, am I audible? Hello.
Yes, sir. Yes, sir.
So it should be split up. So like this. Okay, sorry. Okay, sorry. So like this, it will 40, then 20 and 50. Everyone got it? How it splits? Okay. So after that, we have to insert 80. So let's check where should be inserted. So 80 is greater than 40, right? It is greater than 50, right? So it should be inserted in this position. Record pointers. Sorry. So it should be inserted in this position. 80, right? So we'll get this. So let insert 90. So 90 is 40 is 90 is greater than 40. So we'll go right. So 90 is greater than 80 also. So it will insert this position, but maximum keys value is 2. So it will split up, right? So 80 will go right, means 80 will go up. So 80 will be like this. So tree will be like this, 40, then 80, then 20, and see 50 is greater than 40. So 50, and the 90 is greater than 80. So 90. So everyone got it, right? Hello, am I audible, right?
Yes, sir. Yes, sir.
Yes, I got it.
Okay, so we'll get this tree after split up. So after that, we have to insert 10. So where, so 10 is less than 40. So 20, 10 is less than 20. So it will insert in this position. So we'll get this tree, right? So after that, we have to insert 30. So see, 30 is less than 40. 30 is greater than 10, greater than 20. So it will insert in this position, but trees maximum can be 2. So it will split up. So 20 will go up, 20 will go up. So when 20 is go up, see this node is also full. So it will again split. So 40 will go up. So resultant tree will be 40, then 20, sorry, yeah, I got 40, then 20, then 60, sorry, 80, then So see 10, 10 is less than 20, so it will like this 10. Then 30 is greater than 20, so 30. 50 is less than 80, so 50. And then 90 is greater than 40, greater than 80, so it will be like this. Okay, so finally we'll get like this 40, 10, 20, 30, 50 and 90. Okay, so let's insert 70. So see 70 is greater than 40, 70 is less than 80, so it will insert this position 70. So a resultant tree will be like this 40, 20, then 10, 30, 40, 80, 50, then 70, and then 90. So let us insert 60. So 60 is greater than 40, so 80, 60 is less than 80. Okay, so 60 is greater than 40, so it will insert in the middle, but this block is already full, so it will split up. So 60 will go up. Okay, so final tree will be 40, then 20, then 80, then 10, then 30, and also 60, and 50 is greater than 40 but less than 60, so 50, 70 is greater than 40, is greater than 60 but less than 80, 70, and 80 is, so 90 is greater than 40, greater than 80, so 90 will be this. So final tree will be like this. So everyone got the insertion how to insert in a B tree.
Yes, sir.
Hello, it is clear, right?
Yes, sir.
Okay.
Sir, these leaf nodes are connected as a linked list, right?
In B plus trees it is connected, but in B tree not connected.
Okay.
So based on this, we will solve one numerical. So please solve. I will wait 2-3 minutes. Please solve in your own way. Then I will solve. So this numerical based on BT concept. So please try to solve. I will wait 2-3 more minutes.
One thing, sir, in B trees. Hello, sir. Am I audible?
Yes.
So, sir, in B trees, do we have this particular order that, like here you are using order of 3? So in B trees we have a do we have this particular order?
No. You can 3 order or 4 order. I gave example. I solve using the order 3. You can also solve order 4, order 5.
Okay. So in B plus tree we use n by 2, right?
N by 2. What is n by 2?
Like n, where n is the number of nodes. In B plus trees, we
Yes.
use, I mean, each node will have n by 2 number of key values, right?
See, in V plus, suppose order is 3. So maximum, you see, maximum numbers of child pointer or block pointers, or block pointer equal to 3 maximum, or minimum should be n by 2, means like this floor value of n by 2 floor value. So what will be the, oh sorry, ceiling value, sorry,
Yes, sir.
ceiling value. So what will it, so minimum should be 2 minimum. So you got it, I think.
Yes, sir. And in case of B plus 3, it is same, right?
Yeah, in case of B plus it is also
Only
same.
difference is we have each we have every key values in the leaf nodes, and there is a linked list structure in the leaf nodes in B
Yeah.
plus.
So
B plus.
in B plus tree, data is stored only in leaf node, but in B tree, data is stored in leaf node also and non-leaf also.
Data by data, you means this 40
Record
20.
record pointers.
Yes, sir. Can you these pointers is pointing to the ID, no, the primary.
Address actually.
Yes, sir.
Ye-
The primary key, no, the prime index primary key, like that.
Yes. So see, in B tree, uh, in B tree, this is record pointer, right?
Yes, sir.
So in B tree, record pointer is stored in internally, means internal node also, or non-leaf also, means uh, leaf node also and non-leaf also.
Non-leaf node also, yes, sir.
But in B plus tree, you see, I will give example that data is only stored in leaf nodes.
Leaf nodes, yes, sir.
Yes. So
So
this is the difference.
one another thing that in the videos I saw professor mentioning that in B tree we have a tendency of increasing the height. I mean, there is a
Yes. Yes.
how is that possible if we if we use the same child or block number of, I mean, numbering technology is same, so how is it happening? I cannot understand that one.
Okay. So see, uh, uh, so in B tree we have to see if in each block we've stored record pointer also and key value also, right?
Yes.
But in B plus trees, only in stores in, means this record pointer only leaf node. So each block size will be less in B plus tree.
Yes, the block size will be less. Yes, sir.
Yes, sir. And uh, and when you insert in B plus tree also, you will see B plus trees it's increased by length, means only breadth side, not by height. When you insert, you'll if you insert in B plus tree, you'll see that it will increase in only, means this breadth. You solve, if you solve some numerical, you will get this answers.
Sir, okay.
You got it now? Hello, Abhishek.
Yes, sir. After solving the numericals, I may get it, sir.
Okay. So how to solve these types of problem? Anyone want to explain how to consider a B tree with the following properties? Block size is 1024 bytes and key size is 16 bytes. Record pointer size is 8 bytes and block pointer size is 8 bytes. You have to find out the maximum order possible for the B tree for the given information. Sorry. Okay. So anyone want to explain how to solve these types of problems?
Here, block size means disk block size in the disk space.
No, block size means this block size. Only one block size. This block size.
Okay.
Okay, so how is the structure of B tree? Anyone want to explain? So
Sir,
yes,
sir, here key size 16 bits mean like let's say for example first name or any name, that is the key, right?
key like this 20 is the key, 10 is the key.
Oh,
So-
okay. Understood, sir.
Okay, okay. So this is the block pointers, then key, then record pointers, then block pointers or child pointers, then key, then record pointers, then block pointers, then key, record pointers, then block pointers. Right? This is the structure of the B tree. Everyone got it, right?
Yes, sir.
Okay, so suppose order is P. So order is P. Suppose order is P. So order is P, then what will be the size of what will be the maximum numbers of block pointers?
P.
Okay. Okay, then maximum number of key will be
P minus 1.
okay. P minus 1. Okay. Then maximum numbers of record pointers will be or data pointers.
M.
P minus 1.
P minus 1, right? Okay. Then C. So suppose maximum is P and the block pointer size is 8, P into 8 plus P minus 1. Record pointer size is 8 bytes plus P minus 1. Key size is 16 bytes less than equal to 1024. So this equation everyone got it, right? So if you have any doubt, you can ask.
Can you explain this equation again?
Okay. See, in each block, uh, if suppose order P, then maximum number of block pointers is P, and the maximum numbers of key will be P minus 1, and maximum numbers of record pointers will be P minus 1. So in each block, maximum can P block pointers, right? Hello.
Yes, sir.
So and block pointer size is 8 bytes, so 8 into P.
Yeah.
Then it also consists key also means
Yeah.
key. So P minus 1 and the key size is key size is suppose key size is P minus 1 16.
Yeah.
And it also consists of pointers. So it's P minus 1 8, and it should be less than equal to total block size is 1024. So it should be less than equal to 1024.
Yeah. Got it.
So everyone got it. Otherwise, I will explain this problem again because this is a very important problem.
Yes, sir. Understood.
Okay. So what will get?
Is it the 1024? Is it size of what is that size
This
inside
block
disk or-
size. It total block size. 1 inch means is block size.
Okay, I'm getting confused
So-
with the block thing in disk actually.
So see, these are the block, like right?
How are these actually stored in the in the HDD actually in the secondary memory? Like
So it is stored in means. So see,
more transactions is coming
suppose
more from your Paytm or a PhonePe,
see,
or are more transactions
so
waiting
can
to
you
get that,
mute?
right?
Okay. See, suppose there is a key size, then record pointer size. Record pointer address of the where actual value is present. This is the record pointers like this. So it will locate the where actual value is present. Means suppose table is like one is table. It consists of records. So it gives the address of those location actually.
Sir, one thing, sir.
Yes, am I audible, right? Actually,
Yes, sir.
network. Okay.
Sir, one thing, sir, can you please scroll up a bit?
Yes.
Sir, here you see this 20. This is it is inside a block, right?
Yeah,
And
inside.
in the right side, it has 60 and 80, which are also inside another block.
Yes, and it will and this is the block pointer. This points to the next node. Means
Mm.
right node or next node.
Okay, sir. This is the block pointer, and one thing, sir, that this
Yes.
20, the block in which this 20 is staying, the 20 is content.
Yes.
That block will have 1024 bytes. I mean, I am
This is
assuming.
this is key size. Means the key. This is a key. 20 is a
No,
key.
I'm talking about the block, sir. This
Okay, so
block will have the 1024 bytes. No.
yeah, maximum means suppose this is a 1024 bytes.
Yes.
So you have to find how many maximum order possible in the means bit tree. Suppose one block has 1024 bytes. So maximum possible orders.
Okay.
So what is the maximum? Suppose there is a one block 1024 bytes, and what are the maximum possible order in a bit tree? So I have. So you
Okay,
got
maximum
the yes, maximum possible. So and
in
you
the right side, there were only the right side block. It contained two key values like this one is 60 and 80. But
yes, yes,
the block size will be same for
yes,
both of
yes. Block size will be same.
this.
So
Is
actually, so
yes.
see, this numerical best means maximum order possible. Suppose there is a one block size 1024. Man, got the questions. What is the meanings?
Yes, now understood, sir. Yes.
Okay. And everyone got this equation. How I means write this equation?
Sir, here the order is P. It means the blocks are number of blocks are P, right?
See, suppose order is P, then maximum numbers of block pointers can be P. Okay, suppose okay, let's give one example. Understand? Sorry. Suppose order is 3, so it can suppose order 3. Order 3 means maximum numbers key possible is 2. So key, then record pointers. Then one is block pointers, then key, record pointers. So this is block pointers. This is also block pointers, and this also block pointers. Suppose order is 3, so maximum is 3 block pointer, right? So you got it this now.
Oh, understood.
block pointer equal to 3, and maximum can be 2 key size. So maximum should be n minus 1. So maximum key will be 2, and maximum record pointers also be true. So maximum so everyone got this concept?
Yes, sir.
Okay, so let's solve this. So 8p plus 8p minus 8 plus 16p minus 16 less than equal to 1024. So 8, 8, 16 and 16, 32p p minus 32 less than equal to 1024. 32p
24.
oh sorry. So less than equal to 1024 plus 24. So 32p less than equal to, what will be the sum?
1048.
148. So p less than equal to 1048 by 32. So what will be this?
32.75.
So we have to give floor value, so we'll get 32. So maximum that possible is 32. So everyone got this numerical, right? How to solve these types of numerical? Hello.
Yes, sir.
Okay, so I'll simply change the value. So please solve one numerical these types. Okay. Okay. So suppose key size is 12 bytes. This is like this is 24 bytes, and this is also 24 bytes. So please solve, find out the maximum order possible for bit tree from the given information. So I will wait 2-3 minutes so that everyone can solve. After that I will solve once.
Sir, is block size same?
Yes, block size is same, 1024 bytes. So I think maximum people got it. So anyone helps me write the equation? Anyone?
The inequality equation, sir?
Yes.
Sir, it was 24p plus 24
24p plus 24
into p minus 1
p minus 1
plus 12 into
12
p minus
p minus 1
is less than or equal to 102.
Okay. So 24p plus 24p minus 24 plus 12p minus 12 less than equal to 1024. So 48 plus 12, so 60p minus 32 less than equal to 1024.
36.
Oh, sorry. 60p less than 1024 plus 36. What is the sum?
So it's 1060.
1060. So p less than its floor value 1060 divided by 60. So what is the answer?
70.
Okay, 70. So everyone got it? How to solve this type of numerical? Okay. So we'll move to B plus T. So see. In B plus T, internal node structures and the deep node structures are different. And in B plus T, record pointers or data pointers only stored in leaf nodes. So first we'll see the internal node structures, then we will see leaf node structures. Okay, suppose there is p order B plus trees. So in p order B plus tree, internal node is like this. So first block pointers and it consists in internal nodes only key values, not record pointers. It only key values, not record pointers. And this subtree, it is strictly less than equal to this key value. And this is greater than or equal to k1, like this. So if there are order equal to p, then maximum numbers of block pointer will be equal to p, and maximum numbers of key will be first I'll see minimum numbers. Will be p by 2 except root node. This is the rules of the B plus J. The maximum numbers of key will be p minus 1, and minimum numbers of key will be p minus 1 by 2. This is the internal node structure.
It does not have record pointers.
Now it does not have record pointers. Record pointer in B plus tree, record pointers only in leaf node, not in internal node.
But there also in B tree also like record pointers, like leaf nodes are only pointing towards
No,
record.
in B tree, it consists in null means this C. This is record pointers. So in B tree, internal node also consists record pointers, but in B tree, only in leaf node. So we'll see leaf node structures after that.
Okay.
So you got it? No.
Yeah, yeah.
Okay.
Sir,
Yes.
sir, here you have written minimum number of block.
Pointer.
Minimum number of block pointer that will
Yes.
be P by 2.
Yes.
Roof ceiling
Except
wall.
root. Yes, except root node.
Okay. Sir.
Yes, root node consists only one also. Only
Okay.
once.
Only once. Okay.
No, only one is minimum 2. Sorry, minimum 2. So minimum 2. Okay. So then we will see leaf node structures. So leaf node consists like this. Key, these are represented key, and PR, these are represented backward pointers. So in B plus T, leaf node structure is key, then record pointers, then key, record pointers, and the add of the nodes, it represents one block pointers represent next to the leaf node, like this. Key, record pointers, then key, record pointers, then this represent next to the leaf node. Key, record pointers, key, record pointers, like this. So you got it. Leaf node structure. In leaf node, suppose order is P, the numbers of Q will be P minus 1, and numbers of record pointers will be P minus 1. So everyone got this means
So this is same. This is same as B tree, right? Order P
no,
and
yes,
number of keys.
yes. So there is one difference. There is one last, and it's linked to the next node. But in B plus is there is neither one block pointers. In B plus is, see, in B plus is does not have block pointer respond to the next node.
Yeah.
But in B plus is there is at the end there is one block pointers is point to the next leaf node.
Okay.
You got it? This
Yeah.
structure.
Yeah.
Okay. So I will insert.
Before going to example, what's the advantage B plus tree offering in comparison to B tree? Like in case of searching and sorting, maybe all those things.
Yes. So see, the main advantage is main advantage is in B plus B tree, records are also stored in internal node, right? Hello.
Yes, sir.
records are also in, so the block size is more, but in B plus trees, records are only stored in leaf nodes, not stored in internal nodes. So size of the block size internal node is much lesser than the B tree.
So can you please repeat?
Okay. Okay. So in B tree, so if there is one. See in B plus tree, records are only means stored in internal node also and leaf node also. In internal nodes, there is a record size, right? So block size is more. In B plus tree, records are only stored in leaf nodes. So block size is much lesser than in B plus tree. Means record size. Sorry, block size. Block size it's to see it's set means in internal nodes. So you got this one, right? Hello, Abhishek.
Yes, yeah.
So
Yeah. So Subhendu, yeah, just one more thing. Yes, Abhishek. So if we use B plus tree, the searching time will be less, right? Because all the data are stored at the leaf node. Where in the case of B tree, the time it will take more time because the data is stored in the internal node also and leaf node also. So if we yes.
Sir was saying at one point in lectures that they are on the same level.
They are at the same level. It's data both
Yeah.
in both the trees.
No. I think in B plus tree.
It is in the same level, right? Because all the data stored in the leaf level only, right? Leaf node.
In B plus tree, right?
Yeah, B plus tree.
Yeah.
So they are at all in the same level only, right?
Right.
Yeah. So as the number of record will increase, the height of the B tree will increase, right?
Right.
So it will take more time to search the record.
Okay.
Yeah.
Sir, this part, sir, can you repeat once again? As the number of records will increase, the height of the B tree will increase, but not in case of B plus tree.
No, means in the B tree we are storing the record at internal node also and leaf node also, right? So searching will take more time in the case of B tree, because in the case of B plus tree, all the nodes are so all the records are present at the leaf node only. So that it
Yes,
will
sir.
directly point to that particular key and it will search the record.
Yes, sir.
Right. In the lecture, sir has mentioned about the degradation, right? So
Yes, sir.
as the number of record will increase, the performance will decrease, right? So in order to to avoid the problem of that degradation, we will go for the B plus tree because all the records are stored at the leaf node only.
No, sir, that I understood, but I cannot understand one thing, sir, that as number of records increases, in B plus tree, the height is not increasing. but in B tree the height is increasing. This I cannot understand. If you can illustrate that with an example, that would be really helpful.
Yeah, sir, I would like to add.
Mhm.
Yeah, in the B tree, you can see what is the structures. When can you draw the B? Yeah,
So which structure?
B tree structure. Yeah, scroll up. Scroll up when there is a block pointer is there. No, B tree. Yeah, yeah. One numerical you have solved. One numerical. Erase it. So the here one structure of the B tree is like there is the block record pointer, and one is husband. Can you draw?
Okay, I'm drawing. Okay. Okay.
B tree. Just only for the order to draw the order.
Okay, order.
Order 2 or 3 maybe will be better. One side B plus tree, order of the B plus tree, and one side B plus tree. Just in the internal node of the B tree, you can see there is a record pointer, right?
Yes, sir.
And in the B plus tree, there is no record pointer in the internal node. So there, in that space, we can accommodate another another key or the block pointer, right?
Oh, okay, sir. Now I understand.
Oh, yeah. So due to this, height will increase, and but in the B plus tree, it is widened.
Understood, sir. Thank you, sir.
Yeah. Thank you.
Okay. So I explained the internal leaf node structure of B plus tree, right?
Yes, sir.
Okay. So let's construct 3 order B plus tree. So Abhishek, do you want to help? Means construct the B plus tree.
Which one will be our root node? I mean,
Means sequentially, means insert 41, then 2, then 43.
okay.
So
41 will be our root node.
okay.
Then we will take 2.
So
2 is then
order 3 means order 3 means block pointer maximum can be 3 and maximum key will be
2.
Okay. And 41 then
2 will be in the left side.
okay, 2 will be the left side.
Now we have to insert 43.
Yes,
So 43 is greater than 41. So it will be in the right side, but we cannot.
so you have to split up.
We have to split it, yes, sir. So 41 will be, 41 will become the root node.
Okay.
Left side it will have 2.
Okay.
And in the right side it will have 43.
41 and 43.
41 and 43.
41 and 43. Yes. 41 and 43.
And this point to the next, right?
Yes, sir. Yes.
Okay. Then insert
38. So
insert 31.
it is less than 41. So
Yes,
it will be in the left side.
means this.
This
Okay.
side, yes, sir.
Okay, so final will be 41, then 2, 38, then 41,
43.
43. Okay. Then after that,
22 will be inserted. So it is again less than 41, but it is less than 38, more than 2. So 38 will be popped up. 38 will become the internal node.
so it will insert 22. So it will be popped up 22, right? Middle of the element.
It will pop up 22. Yes, yes. It is in the middle. 22 will become in the middle. So yes, sir.
22, 41, then 2, then
38, 22, 38. 41 and 43.
so it will point to the next node, and this will point to the next node. Okay. After that, we have to insert 90, right?
Yes, sir.
Okay, let's read this. Okay, so when we will insert 90,
Here, sir. Yes, sir.
so 43 will be pop up,
Yes, sir.
and
But then it is full. So in again we have to pop up 41. So 41 will become the root.
okay, so let's do 41. Left will be 22, right?
22. Right will be 41 and no, not 41. 43. Only 43.
43.
In left
Right will be 2.
2. Yes, sir.
22, 38, right? You got it? Hello?
Yes,
Hello.
sir. Actually, I am muting myself because there is a position going beside me.
Oh, okay. Okay. Then 41. Then 43, 90. So let's draw in pair way. So 1, 2, 3, 8. Respond to the next node. 41. This will point to the next node. 43, 90. So everyone got the insertion of mean B plus this. Hello, am I audible, right?
Yes, sir.
Okay. Okay. So next,
Can we traverse this? I mean,
yes.
can we traverse the tree?
So I have to traverse the tree, right?
If I want to go from, I want to access 41, 42, 2 and 22, then how can I traverse this?
So see, 41. So 41 is less than or greater than 41 is greater than, right? So you have to go right. Then 40 is less than 41. So you will get record pointers in this. Okay.
So how to perform deleting in the B plus tree and B tree?
Okay. B deletion is not in the syllabus, so we'll some delete the. We'll see some how to delete the. We'll want to our example. So after the you will understand how to delete this.
Okay, okay.
Okay. So let's first solve some numerical. Okay. So consider a B plus tree with order 2 and level 6. So what is the maximum numbers of block pointer at level 4? So this is a very important question. So I will wait 2-3 more minutes. After that we can discuss. Please try to solve these types of questions. So anyone want to help how to proceed these types of problems? Hello.
Is the answer 2 per 5 or something?
So how to proceed these types of, okay, so see, order 2 means
Root node will have
maximum block pointer is 2. Okay, so and maximum key will be 1. Maximum key 1. So at level 1, maximum block pointer is 2, right? 1, and this block pointer and this block pointer.
Sir, that is level 0, no?
This the height and this steps, the level and height is different. So this like see so we consider level 1. This is
Okay, sir.
okay. So maximum block pointer is 2, right? You got it?
Yes, sir.
In level 2,
4.
okay. So level 2, 4, 1, 2, 3, and 4. Level 2 is 4. In level 3,
16.
level 3,
16.
8.
16, sir.
okay. So this will this okay. So level 2, 1, 2, 3, 4, 5, 6, 7, 8. You will get 8, right? Obviously, you got it.
Sir,
Yes, sir.
At 0, right?
Yes.
At 0, right?
At,
This node is level 0, right?
consider this is level 1.
Okay, sir.
Okay, so level
yes,
1
sir,
will be
yes. Got it.
So is it like order power and what will be
yes,
the
sir. Yes, to the power 1. Then level 2 is to the power 2. So level 3 will get to the power 3, right? Hello.
Yes, sir.
yes, sir.
Okay,
And level
so
4 is too powerful.
level 4 is to the power 4 equal to 16.
Yeah.
Okay, so we'll move to next question. So consider a B plus tree. What is the minimum numbers of child pointers tree and that can be placed in a non-root node? So we'll wait 2 minutes. See this. Hello. Hello.
Yes, yes, sir.
These types of questions by default we consider level 0. So
Okay.
we assume level first one. So by default is level 0.
By default, level 0 means the root node will be in level 1.
Ye- uh, yes, root node will be.
Root node will be on level 0.
So, sir, the formula will be order to the power level plus 1, right?
Yeah, then it should be like that.
Mm,
Because sir, at level 4, if you add 0 here, it should be like 2 power 5, 32.
yes, yes. So see,
Whatever you have calculated is up to level 3, according to what you have
okay. Okay.
right now.
So let me solve 1 second.
Yeah, sure.
Okay, so this types of question may confuse. Okay. So this is a level 0, right? So at level 1, so block pointers will be 1 block pointers, another 2 block pointers, right?
Yes, sir.
So 1 block pointers and the 2 block pointers. Okay. Sorry. So sorry, I'm a bit confused. Sorry. So level 1.
Yeah, it's when the instead of level 0, you can see there is the 2 pointer, right? A 2 block pointer.
Okay. Level 0.
2 block pointer, right?
Okay.
In after that it's the level 1. Yes.
Level 1.
There is the 4 block pointer.
Okay, 4.
For the left side there is 2, and the right hand side there is 2.
Okay, so 4 block pointers.
So after ends the level 2, you can see
Level 2.
2 into 4. 2 into 4.
8 block pointers.
Yeah. And the level 3 it is
16.
Yeah.
And level 4.
um,
32 block pointers.
32 block.
Okay, so everyone got it.
And then you have to just sum up.
So I asked what is the maximum number of block pointers at level 4. It's at level 4, there will be 32 block pointers.
Yeah, Abhishek and
Yes, sir.
it is clear to you, right?
Yes, sir. Yes, sir. So, sir, the formula is order to the power level plus 1.
Yeah, you can write the formula as the there is n pointer 0 to n. Can you tell what is your formula?
Level plus 1. So means there is level 0 means to the power 0 plus 1. Level 1 means to the power 1 plus 1. Okay.
So what is the answer? 2 to the power 5, that is 32.
General formula is like order power level plus 1.
Okay, yes. So
Yeah, that is the right formula. Yeah, 2 to the power level plus 1. 2 to the power 5, that is 32. Thank you.
okay. So please, so I will wait 2-3 minutes. Please solve this question. So in this question, you have to say minimum number of child pointers and the minimum numbers of keys in B tree. And this is a non-root node. You can respond in chat. Okay, so anyone want to help how to go these types of problem? Hello, am I audible, right?
Sir, for the minimum number of child pointers, I did order 17 by 2.
So minimum numbers of child pointers equal to 17
17 by 2 is
means
9.
okay, 9. And the minimum numbers of keys
17 minus 1 by 2.
Okay.
Ceiling value.
n minus 1 by 2. 17 minus 1 by 2. So you will get 8 keys
Yes, sir.
and 9 points. Okay. So consider a non-empty B plus tree of order 17. What are the maximum and minimum numbers of keys that can be placed in the root node? So I will add 2-3 minutes. Okay, so order 17. So maximum numbers of keys will be key will be 17 minus 1 equal to 16, and the root node minimum will be 1. So everyone got it? Hello?
Yes, sir.
Okay,
So
so
basically, there can't be more than one root node, right?
no, it can be more than one root node, but minimum will be 1. In V plus T, it can be one more than one root.
Okay.
So in this, for example, we also said there are more than one root node. Okay, see. Okay, so we'll move to another question. So consider a B tree order 3. If you have 9 elements to be inserted into the tree, then what will be the maximum numbers of split that take place in the nodes? So please try to solve, and please there is a one trick in these questions. So I will wait few minutes.
Sir, in the previous question, the minimum number of root node, will it always be 1, sir?
Is key see. Okay, let me. Node will be root node. Sorry, let me clear. Root node will be 1, but key can be more than 1.
Oh, okay, sir.
So anyone want to help me how to go ahead these types of problem? Abhishek?
Sir, I solved it, I mean, diagrammatically. I did not solve it mathematically.
Okay. Okay, so there is a one trick that there will be maximum splits. So can you
So,
tell what is, so when it will be maximum numbers of splits?
I mean, the root node should have one element, first of all.
Yes.
One key, that is.
Mm. So when it will be left skewed or right skewed, then it will be maximum, right?
Yeah, sir. Like if
Yeah.
every value is greater than like increasing order and decreasing order.
Oh, then it will be maximum.
So I
Okay, so-
like just the way he told, like I solved it diagrammatically and I got 4.
Okay.
If
No,
I
no,
don't
but
know like that is true, like correct
no,
or not.
it's not correct. But
Okay.
you tried well.
Okay, thank you.
Okay, so let's solve. Suppose let's take one example like 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
Yes, sir.
Okay, so order is 3. Maximum block pointers will be 3 and keys will be 2, right?
Yes, sir.
Okay, let's insert 1. Let insert 2, then 2. So let's insert 3. So when you will insert 3, maximum key will be 3. So we have to split, right?
Yes, sir.
So we have to split from middle. So 2, 1, and 3. So let's count the split first. So split will be 1. Okay. Okay, so let's insert 4. So when we insert 4, so what will be the final?
We said 3.
Okay. 1, 3, then 4. Okay. Let insert 5. So we'll let insert 5. So what we'll get? 2, 1.
We said 2, we will have 5. We said 2, we will have 4.
So you have to split, right?
Yes, sir.
So it will go up, right?
Yes, sir.
Okay, so let's remove. So we'll get 2, 4, then 1,
3.
then 5. So number of split is 2, right?
Yes, sir.
Okay. Then let insert 6.
6.
So it will be
It will up to 5.
4, 1, 6, right? Okay. So let's insert 7.
Inside 6, it will be inside and 6 will be popped up.
Okay, so I will insert 7. So it will pop out in this position, and
And then again 4 will be there.
then again 4 will be popped up. So let's intermediate node, so that will be better. 3 to 4, then 6, not as final. Sorry. 4, 6, 1, 3, and then 5, then
7. 7 will be that side, yes.
7. So this will split up. So 3, and this will also split up.
Split up.
Okay, so
4 will become the root.
So 4,
2,
2, then 6. Then 1, 3, 5, 7. So split up is 4. You got it until this? Hello?
yes, sir.
Yes, sir.
So, okay. So let's insert 8. So when we insert 8, it will go in this position. So intermediate will be 4, then 2, then 6, 1, 3, 5, 7, 8. You got it?
Yes, sir.
Okay. Then you have to insert 9. So
It will got split up and move ahead above.
yes. So
And we have like 5 splits.
yes. So 4, then 2, then 6,
6 and 8.
1, 3, 5,
In the middle.
so total split up is 5. So everyone got this question?
Yes, I got my mistake also.
Yes.
Is there a way to solve it mathematically?
I did not know, but I don't know this.
Sir, I don't think so, right?
Yes, sir. Yes, I don't think it will be solved in mathematical, but there is some way. I don't know. So if there is a way, I will tell in next session.
Okay, sir.
Okay. So everyone got this answers, these questions, how to solve. If you have any doubt regarding this numerical, you can ask.
The practice assignment, there is a similar question.
Oh, okay.
Question number 6, it's a numerical. Can you please solve that?
Number 6.
Yeah.
Okay. Yes. Okay. Let me stop here.
So won't you cover hashing in this session?
Yeah. So 6:47. So we'll discuss on tomorrow. Saturday session. That will be better.
Okay, that is from 9 to 11, right?
Yes. Yes.
Okay.
Hello. Am I audible, right?
Yes, sir.
Yeah, this is the question, right?
Yeah.
So in the question there, consider a B tree based index order 19. Okay. Right. And here you can see assume the B plus tree is 73% full. So each node is only 73% full. That means how many are block pointer are there? So you have to calculate. So how to calculate that? 9 into, right, and that is approximately 14, right? Up to
Yes,
this
sir.
is clear. Yeah. So now your next. So now you assume this particular thing as the 14 is your order and number of key is. So what is the numbers of key?
13, sir.
That is 13, right?
Yes, sir.
So now calculates the what is the question that the maximum numbers of keys. So you have to see up to height of the tree is 3. So you have to see up to, first you have to check level 0 and the level 1, level 2 and the level 3. So level 0 numbers of node is, tell me how many numbers in the level 0? Only one is there, right? Yeah. Hello.
So, yeah, only one node with 13 keys.
Yeah, that is 13 keys. And after, tell me numbers of block pointer.
14 pointers.
14 pointer, right? So okay, that is number of node is 1 and the numbers of key is 1 into 13, right? 13, and that is 1 into 14, that is the numbers of block pointer. Similarly, in next levels, the numbers of nodes is, this
14.
is the numbers of node 14, right? So numbers of keys in that 14 into
13.
13, right?
Mm.
In the next numbers of pointer is 14 into
13 into 14.
14. In this way you have to calculate it.
Okay.
Yeah, up to this
And
point.
add up all those things, right?
Yeah,
Finally.
up to this and just sum of this one. Yeah, you get the idea, right?
Okay.
So can you
Right.
please repeat it from beginning?
Yeah. So here in the question given, the original order is 19, right? So
Right, sir.
19. So how many block pointer is there in order P, B tree?
It's 19.
In 19. So in question, it is given the 70, on an average, each node is 73% full, right?
Right.
So that is 73% full. So up to, so suppose each node is filled to this numbers of node key value, right?
But sir, each node like is 70%. Like
Yeah,
node
yeah.
1 is 73% full, node 2 is 73%.
Yeah. That is. So this is 73% node. This is 73% node.
Yeah. Yeah.
So we can assume that this is the original order. We can assume that.
Okay.
Next, modified order. So what is the modified order of that node? So how to calculate the modified order of that node? So this is the way. 19 into 73. So we get modified.
So we basically calculated total numbers of nodes which are like total area which is full.
Yeah.
Okay.
So in this way you get the 14 is the after calculating you get something like new node is like this is the your new node, and 14 is the numbers of block pointer, right? So in 14 block pointer, 13 is the possible numbers of keys.
Wait, 13 like according to like 14 block pointers are full, right?
Yeah.
Okay.
Then how many key are possible in that
14 in 13.
13, right?
Yeah.
So after that you have to calculate the what is the maximum numbers of keys up to level 3, right? So you calculate every time in each level, so there is the 13 key, right?
So do we need to apply unitary method?
No. How can you apply the unitary methods? You have to calculate for the each level, right?
Okay.
Oh, shall I complete this solution?
Yeah, please complete.
So up to this is clear to you, or shall I?
Yeah, up to 13 I got it.
So let me write. There is level 1, level 0, level 1, level 2, and the level 3. You have to calculate and so up to level 3. So in the level 0 numbers of nodes.
Isn't it mentioned height is 3? Wouldn't that mean
yeah. That is height is 3, right? Right. So can you tell what is the height of this tree?
It's 2.
Yeah, that is the level 0, level 1, and the level 2, and that is the height.
Okay.
Yeah. So you got it. Why I write the level 0, level 1, and level 2, and the level 3, right?
Yes, sir, I got it.
Yeah. So in the root nodes, the numbers of node is only 1, right?
Yes, sir.
Only one node, and after that the numbers of keys. So in the order 14, the numbers of keys is possible 13.
Yeah.
Right. And after numbers of block pointer
14.
Yeah. That is 1 into 14. Right. In the second levels, the numbers of node is 14. Right.
Yeah.
14. So 14 into 13, that is, I think 82. And 14 into 14 is 96. After that, here the 96 node is the level
So why
2.
why are you multiplying it like 14 into 13? Okay,
So
okay,
you,
okay, got it. Good.
yeah. So 96 or 196 into 13. So please calculate it.
Yeah, I'll do after
Yeah.
this.
After here you get 96 into 14, right? And the next level you get the 96 into 14. So here 96 into 14 into 13. So suppose this is y, this is x. You have to calculate only this value, right?
Yes, sir.
So I think that is right. So this is the answer, right? Okay. I hope it is clear to you.
Yes, sir. Clear.
Yes, sir.
Yeah. Any other doubt? Practice question. Week 9 practice question. Any doubt? Any question?
Sir, 9.5, question number 2.
9.5 activity question.
Yes.
Anjana, would you like to? Hello. Okay. So can you tell what is the question?
So it is based on the index, create index.
Oh, so you know the how to create the index, right?
Yeah, that I know. The doubt, specific doubt it is here is creating index on more than one field. There is a
So
question like supplier ID greater than 1000 and part ID equal to something, and supplier ID equal to and part ID equal to. So there is two like create index supplier ID on suppliers, supplier ID comma part ID. The other option is part ID comma supplier ID.
hello.
So like how do we identify the order, because how can we judge which one has the major value and which one has the less value?
Yeah, so actually it's based on the use case. Like suppose like in this question we have mentioned, suppose the commonly used query on the table will be suppliers, right?
Yeah, supplier ID and part ID.
Supply ID and part ID. You can see in the both the query. Yeah. So if we are performing any query on particular attribute, so that attribute we have to mention in that the specific order, like first supplier ID and then part ID.
In the order where how it is shown in the where clause.
Yeah, on which, yeah, not in the where clause, but so suppose we are mostly using, okay, let us take one example of student database. Okay, we are having attributes, roll number, name, age, and Aadhaar card. Okay,
Okay.
So suppose I am performing query. So mostly perform query based on the roll number only. That is key, right? So if you want to create an index based on the multiple attribute, then you can put roll number as a first key or first attribute, then comma followed by the name or Aadhaar card, Aadhaar number. So it depends on like which query, like on the database, which query we are performing, like most commonly performed query. So basically it is a primary key only, right? So whenever we want to retrieve any record, like in the case of student database, we generally use a roll number, like if you want to fetch any information about any particular student.
Yeah, but like how do we judge whether roll number should come first or Aadhaar number should come first?
Yeah, roll number is the key here. If it is mentioned specifically roll number is the key, then we should use roll number first. Or if it is mentioned Aadhaar number is the key, then we should use Aadhaar number. So whatever the key is there in the table, we have to use it first. Okay.
But in that specific question, I don't think anything is mentioned like that.
Question is not mentioned. Okay.
9.5, question number 2.
Okay. In supplier table, part ID is also there. Okay. Yeah, the supplier ID should be underlined here. Means it must be a primary key. Right, Pradeep? Supplier ID must be underlined there. It should be a primary.
Yes, sir. Here you can see there is question mentioned that the whichever the preferable. So if both are the answer, then you have to choose which is the most appropriate. Yeah. So
no, in the question
think
we should mention that supplier ID is a primary key.
If supplier ID is mentioned as a primary key, it should come always the first.
Yes.
So if it is not mentioned, is there anything like how can we judge?
So it's based on the most commonly used query in the database, like as I said in example.
Yeah, that is the like number the order I am asking. Which one should come first? Because options giving supplier ID first and part ID second, and part ID first and supplier ID second. So
in the question we should mention supplier ID is primary key here.
Okay.
Yeah. We always use primary key at the first place. Okay. Whenever we are creating any index.
Okay.
Yeah. So if you go to PG admin,
it's nothing related to that greater than sign in that, right?
No.
Okay, just that confused with that. Okay, so thank you.
Yeah. So just go to PG admin, create any index. So not index. If you create any table and if you put one attribute as a primary key, then it will automatically create a index on that particular primary key. Okay. And to check that index, just select. So just write a query. Select star from PG underscore indexes. Okay. So you will get the list of the indexes that is there. And based on particular table, there is one index. Okay. There is unique index for each table. And the index is generated based on the primary key.
Okay.
And by default, Postgres is using B-tree to create the index.
Okay.
Yeah. So just go to PG admin, just run the query, select star from PG underscore indexes.
Okay.
Yeah.
Sir, if there is no primary key, then how will the index be created?
Then we have to create the index, right? Based on the.
Okay, so we have to do it ourselves then.
Like create index, then table name, not table name, then index name on table name. Then in the bracket we can mention the attribute name. And in the PG admin, I guess at most we can mention 32 attributes in a particular index. If a table is having more than 32 columns, then we should like at most it is taking on 32 attributes only.
Yes, sir. Professor told that in the lecture video also. And one other thing, sir. So let's say I don't have a primary key, so and I am using a column which has duplicate values. So
Duplicate
in that
values.
case, yes. So in that case, will there be any problem while creating the index?
Yes, yes. Yeah. If it's having duplicate value, then it will create a problem. Like which record? Like,
Yeah.
duplicate.
For the duplicate value, there is also indexing is there for the duplicate value.
Okay. So I mean, it will then go just by sequentially. It will assign a number.
No. In the there is indexing. There is the duplicate indexing is also there for the duplicate value.
I mean, what happens in that case, sir? Can you please explain?
For that we use that duplicate value for the indexing. Yeah, I think that is called the secondary indexing.
Okay. Yes, sir.
Yeah. So you already read about it, know about it, the primary indexing, secondary indexing.
Yes, sir. Secondary
Yeah.
index is basically another index where we keep track of the primary index.
Yeah. If you are using retrieving record using other than the primary key, then we are using the secondary indexing, right?
Other than primary index, yes, we are using. So let's say I have two name or two same name, like two Abhishek Bose. So
Yeah.
So in the primary index I will have the same value. Like let's say I have a 10, and then second Abhishek Bose, he will also have a 10. But in the secondary index we will have single index value. Let's say an 11 or 1 or something like that.
No. You have both the primary key for that. Suppose the student ID is different of you, both
No,
of
sir,
you.
I am saying a table without primary key, and the column that I am using to create the index that has duplicate values.
Yeah. For that, we are using the secondary indexing.
For that, we are using secondary index. But sir, I mean, how will the indexing be done? Can you give an example, small example?
Small example, like there is the instructor tables, there is a department. So you apply frequency, frequency apply the query like that. Select the faculty name from suppose the physics department, or you apply the same thing. Suppose the numbers of faculty from the music department, right?
Sir,
So
your voice is breaking, sir.
Okay. Hello.
Yes, sir.
Yeah. So suppose you are applying the SQL query, frequently SQL query of the instructor tables that select faculty name from the physics department, right?
Okay.
Similarly, select the faculty from the music department, right?
Okay.
So you are using again and again the department name as the to filter records, or using that. Yeah, but you can see the department value are not unique.
No.
No, that is not unique, right?
No, sir.
No. So in that case, we are using the department table for the indexing, right?
Okay.
For the easy retrieval of the data, right? For that purpose, we are using indexing, right? So we can retrieve the data from the database easily. So
Yes,
that's
sir.
why, that's why we using the indexing file, right?
Yes, sir.
So
That I understood.
yeah.
So, you have said that physics, we are selecting faculty name from physics department.
Yeah.
So let's say we have two faculties of same name.
Yeah, possible.
So in that case, the first faculty name, the first name of the same names
Yeah.
will have will have an index, and the second name will have the consecutive index number, right?
Consecutive indexing number,
I mean,
can you
let's
be
say the
specific?
first faculty name, based on the faculty name, the first faculty name gets 10 assigned as the index number,
Yeah.
and the next faculty name gets 11 assigned as the assigned as the index number. And the thing is, both the faculty name are same, but their index number is different. That will be the case, no sir?
No, I think you are making the misunderstood the concept of the indexing, I think. So, okay, let me explain again. So, is it visible? Right?
Yes, sir.
Hello?
Yes, sir.
Yeah. This is index file, right? So in the index file, this is the search key and this is the block pointer, right? There is the only two values we store, the search key and the block pointer, right? And here is the instructor table side, instructor or student. So this is the name, right?
Yes.
And so this is the department number, right? So let's say this is the Ashutosh from physics department and the Ashutosh from computer science department, right? So now tell me, what is your you want to create index based upon which value? Name or department? Name,
Oh,
right?
Name, yes, sir.
Yeah. So here you can see this value are not unique. Yeah.
Yes, sir. Yes, sir.
So I not exactly which indexing is there. There is also one indexing is there. So we can only store the one of the, there is the possible duplicate value, only one instance of that value if the value is sorted, right? For the name, I think it is not sorted. So we can take the entry of each value if it is not sorted, right? So Asutosh and the block pointer is point to this particular, and
Yes.
second is Asutosh.
For that, we use secondary indexes, right? If it is duplicate value, if they have duplicate value.
Oh, that is secondary index. I'm not exactly remembering the name of. And
So what
yeah.
if both are from physics? Ashutosh physics and physics, because it can be possibility.
Yeah, then that is not unique. That is the duplicate value. There.
No. That is the possibility that there are two Ashutosh in the physics department.
Yeah. So yeah. So we pointed to this particular also. Yeah. Your main task is how to retrieve the data, right? From.
Yes.
Yeah. So suppose you want to write the SQL query like that, select star, I think, and the from instructor, where name is name equal to Ashutosh, right?
Okay.
So if you want to apply this particular again and again, suppose there is the name equal to Pradeep, right? So yeah, name equal to Pradeep. So you using this particular columns again and again. So that's why you create an index for that columns, right? Yeah, that is the use of indexing, right? Retrieval. So suppose if you want to find the department as a name of the instructor from the physics department, every time you apply the query again and again, suppose the department instructor from the music department, right?
Yes, yes.
So then you create index based upon the department. Yeah. So you know about that on the duplicate value. Once there is a duplicate value is present, so we create for the we create the dense index, right? So for the every records we create an entry in the index file, right? So I think this is the one of the case of that use case of that.
Okay, sir. So every for every record, one index file, one record will be created in the index file.
Yeah, yeah. That is dense index.
So in
If
the
you-
record, the search key will be same, but the block pointers will be different. That's how we
yeah.
That's how
So-
we can recognize each and every duplicate value.
Yeah.
Okay, sir. Okay, now understood.
Okay. Any other doubt?
So bitmap will be covered in next session.
Yeah. I think most of the student lived. So
Okay.
we will discuss on the Saturday.
Okay. And like in this week, like it's a very theoretical week. Is it sufficient to rely on the material which we covered in live sessions?
Yeah. Numerical we discuss on the live session, and the slide is sufficient for the examination.
No. If we go through the slides with professor slide, like there are a lot of theories. So is it sufficient whatever we have covered in live lecture is sufficient for this week?
Yeah, you can go through the slide and lectures, but if you see the important topics here, what you have discussed, 2, 3, 4 tree, B plus tree, B tree, then hashing part is there, then indexing part is there, right?
Yeah.
Yeah.
I mean, sir, in the previous week, for few questions, we have to refer either to the internet or to the book that is used for DBMS. So like that, I mean.
On which topic? Oh, that magnetic
Sir,
part, numerical.
Numericals, yes, sir. One numerical like that, number of blocks, something like that. Number of blocks and number of tracks. That one. And another one, that is question number 4. I remember that in heap file structure, we have to reorganize file every time. I mean, two statements were given. In heap file structure, we have to reorganize file every time, and in sequential file structure, when the I mean disk size is full, we store it in some buffer or some block or something like that. This question. So for that, I have to refer. I actually first I refer the internet, but in the internet wrong information was given. I mean, particularly there was a particular website I went. Then I referred to the book. Then I got the answer.
So
Yeah.
I think reference book is sufficient.
Your core reference book is sufficient, right? In the internet, like many students have different perspective about that particular topic.
Yes,
So-
sir. So I mean, in the internet, I found out that the statement for the sequential file storage, that was written for the heap file storage. Like in heap file storage, when the storage is full, the file is stored in a new block or something, some extra block, something like that. That was written for the heap file storage, but it is true for the sequential file storage. So that was a misinformation. So like that, do we have to refer the book this week also? Because previous week, like let's say week 5, week 6, lecture videos were enough, and of course we got help from live sessions as well. That goes without any saying. But lecture videos were enough to solve. But this time, in week 7, I found that we have to go beyond lecture videos. So is that true for week 9 also?
So yeah, if you want to understand the topic in depth, you have to go to the reference book, right?
Yes, sir. That is true.
Yeah. So when we discussed with the professor, sir, professor also mentioned same thing. Like there are many reference books. Like the concept may be little different, but whenever there is a contradiction with among the concept, we will stick to the course reference book.
Okay, sir. That is also helpful. Thank you, sir.
So in the last week, we have also taken one live session based on magnetic discharge. So in that we have discussed the numericals, like various numericals based on that.
Yes, sir. Yeah, I saw that video where you discussed numericals. But I think you did not discuss regarding that block size or regarding block. Any numerical you did not discuss.
Okay.
I think, sir, I am not saying that you did not, but I think regarding block or block size, no numericals were discussed.
Okay, we'll see that. Yeah. Subhendra, you have taken that second.
It is no problem. I'm not complaining. I'm just saying that.
Okay. 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 Any doubt in this in this week? Any other doubt?
If there is no any doubts, so we can
We can wind up the session. Yeah.
Thank you, sir.
Yeah. Thank you.
Thank you everyone.
We have scheduled one extra live session for SQL practice on Monday. Okay. We have also pinned that on Discord. You can check your DBMS calendar also.
That is for SQL query, right?
SQL query. Yeah.
Okay, thank you.
Okay. Thank you then.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.